I thought I'd start with a joke. My question is, do you know why Usain Bolt doesn't like dynamically typed programming languages? He doesn't want any errors at runtime. There's going to be more jokes. So
still all in the room.
Thanks for checking. Yeah, I guess basically, you know, the whole point is like the web is everywhere, and I guess the other kind of observation, you know, is moderately concerning. Is like there's definitely a lot of things being written in JavaScript. A prediction I calculated earlier is actually it's going to surpass all the known things. That's in the future though, so moderately concerning. But I guess like the other kind of thing I wanted to mention, I don't know if people know this Godwin's law, but there's another one that I've discovered recently, NVIDIA's law, which is like, you know, eventually just a company will be like, shouldn't we be doing AI? So, you know, I guess I just wanted to open up a question to the audience. Have you seen any cool deep learning AI things? AlphaStar, good guess. Yeah, the game playing ones that played Go and StarCraft. Anyone else seen anything cool? Great, no other cool. Well, you're going to see some cool things then. Sorry, what?
Style transfer stuff.
Style transfer, yeah, very cool. Style transfer is very cool. Yeah, I just thought I'd share this photo. Does anyone not know who NVIDIA is? One person. So NVIDIA makes these things here called GPUs, and so they're kind of powering a lot of deep learning. So I guess what I wanted to do is just talk a little bit about the kind of the language we use to talk about deep learning. And that's neural networks. And the way I wanted to do it is by, suppose you have a shop. I like clothes, so I'm going to suppose my shop sells clothes, and I've got a theory. My theory is that when I upload a new T-shirt on Instagram, the number of sales in real life I get are related moderately to how many likes it got. Does that make sense? There's a theory about retail. You know, oh, right. And the reason I have this theory is because I have data backing it up. So I've like put it in Excel, you know. Great. So I'm going to make my theory a little bit more precise in the form of a kind of wordy equation and then a symbol-y equation. So the way I've transformed my theory is now I'm going to suppose, well, my sales is exactly equal to something times the number of likes. Does that make sense?
Yes.
Great. And now I have a neural network. And so really all I've done in that little picture is just kind of like swapped, you know, the L and the S. And the way I think about that is because, well, I want to compute S. So what I do is I provide an L and a W. Great. Maybe some people know about neural networks. So what's missing from this picture, if anything? I mean, it's learning. I like bias. True. Anything else? Sorry? Levels. Right, because it's deep. we gotta make it deep somehow. Solid. Was there another? Sorry, a browser. Yeah, browser. Good point. We are at the Web Meetup after all. All right. I don't think I had any of the things. Maybe I had one of the things you said, but there's this, people often throw around this word activation function. There's this kind of loss word, like how badly is my network performing? And some words that are going to come up later that I'll give you some pictures for are layers and kind of fully connected. So the main business of kind of neural networks or deep learning or machine learning is learning the parameters from the data you have. And so the parameters to our earlier theory was simply, well, there was the data, which was the number, which was L, and the parameter was W. Does that make sense? Great. And so now that I have this little diagrammatic language, what I'm able to do is draw richer diagrams. And the two things we talk about is training our network to match existing data, and what will become relevant is inference to kind of run our model on new data. Any questions about that? It's all super clear. Already knew it. Boring. Great then, I have a question for you. So a trained network that we're going to use for inference, it consists of the network structure itself, that little picture, but what else? Set of weights. What was your answer? The data. Yeah, you could think of the data. The weights was kind of the answer I was after. The learned weights, which we recall are the parameters we're trying to remember. So who has heard of TensorFlow? This is incredible. I should have started at a different part. But the point is, for those that are not familiar with TensorFlow, is it's a system for kind of computing math functions on vectors and matrices. You can run it on those things, the GPUs, and we typically use it to do kind of these two areas of maths, linear algebra and calculus. Just for anyone that hasn't seen these things before, we call the first thing a scalar, the second, the kind of the in Python or JavaScript, you might call that a list, the vector. And you'd call the matrix a list, a multi-dimensional array, or a list of lists. Any questions about that? It's all very clear. Great. So we're going to have an example now, and I believe it proceeds like so. So has anyone used this thing here called Google Colab? One person, 2 people, 3 people. A few people. So what I have here is the ability to write Python code and evaluate it on the internet. And I have done so. And people that have done kind of high school math or something might remember the formula for finding the hypotenuse of a triangle. You have like a squared equals b squared plus c squared, whichever way around it is. And so here I am computing that in NumPy. And what I want to show you is that I can also compute it in TensorFlow. And in fact, because I was practicing this talk, I've already computed it. but I did also give myself a hint. And the main hint was to use tf.math.square root. The point is, in Python, if you're not familiar, these operators, the double star and the plus, can be, I think they operate overloading. So they kind of create TensorFlow objects, and then with any luck, you can run this function like so. 3, 0, 4, not 0. And what we see is that is a tensor whose NumPy value is 5. And if you check that in your head, 3 squared plus 4 squared is almost definitely 25, and the square root of that is 5. So It checks out. Thanks. Thanks for verifying there with me. The other thing I wanted to show you, and I'll just kind of mention this. Who remembers computing derivatives? Several people, and someone got annoyed. You don't have to compute derivatives in this talk. But what I just wanted to show you is that, with the elaborate mechanism of TensorFlow, we can compute the derivative of this function by hand. And then we can ask TensorFlow to do what we just did up there. And all we're doing is we're evaluating the derivative of the function x at the point x equals 9. And I'm going to run this, and you're going to see that that's 18, which is 2 times 9. Checks out. Whatever. The only point here is to observe that we're computing derivatives. And that's kind of the calculus that I promised we'd be talking about. So the whole gist that I'm trying to get at here is there's TensorFlow and there's tensorflow.js. And you should be able to do the same things with both of them. And the point that I want to get across is that this is powerful. So we just, no, we have not done this. So now let's do the same thing in JavaScript. So what I'm going to do here is open up my code. Is that big enough for everyone to read? Yeah. I've given myself some solid hints here and not the answer. So let's give it a go. tf.square root of tf.pow a2. Wrong. And then I need to do tf.add of that. And I put my commas there. b2, like so. And then I probably want to return it. Someone got angry that I did that, so I'm going to remove it for you. Oops, that didn't work. Like so. Is that JavaScript like offensive to people here? I haven't done much JavaScript. Moderately offensive? Not offensive. All right, let's run it. 5. Yeah, it's an array because we typically want to compute over a vector or a matrix. You very rarely want to do deep learning with just one number. That's that example. And there it is again, just for reference. Great. Now we're going to wildly step up what we do. So what I want to do now is completely define, train, download, and then run in the browser a model that does classification on these small images of types of clothing. So what we have here is, you can see the tiny images up there. There's like I believe that top left thing is called an ankle boot. I think I'm wearing ankle boots, I have to tell you. And so on. The rest is clear, but there's 10 types of items. And we want to basically feed an image and have the network tell us which item it is. Does that make sense? Okay. So I'm not going to do it all. I have done some of it before, but what I just want to show you is how little code it is these days. So who's done Python? Raise of hands. Most people. Yeah. So we just need a library that they call tensorflow.js. With any luck, we can run this one, import it. TensorFlow is pretty convenient in that it actually has our what's called fashion MNIST data already available. So I can just go, well, I will have the train images, the labels, which refer to like, given an image, was it a t-shirt or was it a shoe? Then I need to do some classic programming busy work. But here's the main business, and that's what I tried to show you in this tiny, tiny picture, is that I argued before that little S to L picture, I could just like draw more edges and draw more nodes, and it'd be kind of the exact same thing. So all I'm going to do is this code here defines exactly this. Any questions about that? What does that mean? Great. So basically, back in our earlier example, we wanted to compute an S, the number of sales we were going to get from the number of likes and this weight parameter. And so what we did is we fed it exactly one variable, the likes, and then it multiplied that by the weight and gave us the answer. Over here, we're going to feed it 784 inputs, and that's going to be the pixel value of a cell in the 28 by 28 image. So it is. So 28 times 28 is 784. And then instead of just one weight, we have many weights. And so we will not be waiting a long time. So let's do it. So here we go. I'm going to define my network. And I'm going to train it. Look at it go. And so this thing's pretty cool, this Google Colab thing, because they give you just free access to GPUs. So anyone can sign up to this thing and use it as you wish. It only stays online for 12 hours. But that's not bad because it's free. So you can see what this is suggesting to us is like you've got a loss number and you want that to go down as time goes on, which it is. And our accuracy, you want that to go up as time goes on, which it does. And so we can print out how well it goes on a set of images that we didn't train on that we refer to as the test set. And so basically it got 87% right. So that's our network that we just trained in that 20 seconds. Any questions about that? Great question. So I have not used that tensorflow.js library I installed. Sorry, I'm seconds away from using that. That was a very good question. This whole time I've just been using TensorFlow. Yeah. So, great. Any other questions? Great. So, this is the whole thing I want to show you here. So this is my file system here on this little virtual computer. Sorry, the font's just going to get a little bit smaller while I do this. So what I did is I had this little model variable in Python. And so I can just go, well, I want to save that model to a file called model.h5, whatever. Then I want to ask this TensorFlow.js converter program. That's what was installed by the Python package TensorFlow.js. I want to say, hey, can you take that little model and output a files that I can use for TensorFlow.js? So here they are. I'm going to download them, like so, and like so. Excellent. Then I'm going to go over here to my little web page that I've set up. And I'm just going to jump into the directory where I'm doing my work here, which is this one. And you'll notice I've got these files in here already. I'm going to delete them like this. And then I'm going to move the ones that I've downloaded, group one to here, and I'm going to move that one. Okay, so I've just moved those files into this little folder structure here. I'm going to refresh this thing. And what I'm going to do is I'm going to take a little screenshot of this thing. Grace, thank you. Wow. What? So the point is, this is running entirely in JavaScript. It is if your computer has a GPU. So mine does not. So the whole magic is that, yeah, you don't need to have a GPU to do inference for certain kinds of problems. So we can just run it again. Why not? We'll try it on like this thing. Ankle. Have to track down an ankle boot. Yeah, still addressed. Obviously, it was going to go wrong when I tried to do another example. That was a huge mistake. Yeah, no, it's fully. Oh well, whatever. But that's JavaScript for you. I was chatting to Gala before, and I was like, "This is absolutely 100% going to work. I'm not worried at all. Why would I be worried?" But you get the point. I'm going to move on. But believe me, I'll come back to that if you wish. I think we can maybe have a look at the error, but it's not going to be too enlightening. It's just going to same error that it told me before, frankly. Do it again. Copy this thing. Last go, I promise you. Yeah, forget it. Let it go. Great. You know, I'm sure we're all familiar with JavaScript always working. But the point is this. I didn't quite show you the JavaScript code that I used to run the model, but it's actually just these few lines here. So the main one of interest is kind of, well, this is where I pointed at my little JSON thing, which links it to the weights. The JSON file defines the model part. And all I do is I go, well, here's an image. Can you read it in black and white and push it into the model and give me the results? And the results just come back as an array. And the point is I trained it in Python. Deployed it to JavaScript for inference. Any questions? It does. Yeah, so that's downloaded to you by the browser. That's right.
Why you want to do this is if I was crazy, would I train JavaScript?
Totally. Yeah, there's an example on the tensorflow.js website where they use your webcam to have it learn. You move your face to like the left side or the other side, the right side, and that tells you, that tells your little car or your Pac-Man thing to go left or right, and they train in the browser for that. I'd say so there are some instances where you can do it. Yeah. Was there a question up the back there?
Yeah, I was just wondering, what's the bin file?
Indeed, what is the bin file is the question, and that is the weights. It'll be a special format that just encodes all the parameters of the network in such a way that you can return them to the correct place in the network. Any other questions? Great. Let's look at another demo which will definitely work. This is one that I wrote a while ago, but what I want to kind of show you, with any luck, is, there we go. And then, or maybe I should stand over here or something. But the point is, it kind of estimates what they call your pose. And so this is just an example that TensorFlow kind of put out just out of the box. They call it PoseNet. And something that I want to talk about in a little bit is just the different ways that we have to think about if we do UX of interacting with AI systems. So the point I want to kind of get across here is this network isn't perfect, but it does all right. Any questions about that? Right now. Yeah, let me just say again about this. What I wanted to demonstrate is the thing that we were doing before, the classifying those tiny, tiny images, you could believe that would be very fast because the data is very, very small. What I want to show you here is this is actually doing moderately real-time inference on a video stream, which is pretty cool. And this pose detection problem is quite a hard one. Let's keep going. Question. Yes, exactly. So what happens is you can write a little JavaScript function that reads from the webcam. And so every step in the loop, that'll just give you a picture. And what I do is, just like I did in my other one, I take that picture, I read all the pixels, I feed it into my model, and what my model returns me, let's say, is a little JSON structure of like, well, your neck is here, your shoulder is here, your shoulder is here. And that's running at like 10 frames a second there, or like 5 frames a second. And that's kind of slow, but my computer doesn't have a GPU in it. So if your computer has a GPU in it, it's actually pretty good.
Do you have to downgrade the image in order to pass it into that network?
Well, there's techniques. So basically, the image that you feed into the network does tend to be pretty small, but I would say that in comparison with kind of like the pose networks that run on regular computers, like it's not significantly downgraded. Another question.
You said it's in the browser. I'm a little confused. Is it running on your computer? Or is it running on like a class?
No, so it's running entirely on my computer.
It's through the browser. It's
through the browser, yeah. So it's all entirely JavaScript. And this one, I can show you, I think. If I go like this and I go to the dance booth and I go to the UI, then the weights. So you can see here, here's the different models. There's a bunch of them. There's like 4 of them. And if I click, I'll just read you what it says. But, that model's actually pretty small. So that's only 2.5 meg that you'd have to download to the browser to run that model. But some of them can get a bit larger. Oh, yeah, there was an error. Yeah. That's great. But this one's about 14 meg. Forget that happened. Any questions? Any more questions? Yo, up the back. Yeah, this is a solid question. I don't think I've seen too many examples of it, I have to say. I mean, I know I'm in the house of Zendesk, and maybe I shouldn't, like, I don't know a whole lot about what they do AI-wise, but I know they do a bit of AI-wise. They do a bit of AI stuff, sorry. And, like, their kind of, like, discovery engine, for example, like, they could have that running in the browser if they wanted to, maybe, let's say. Because it's like you could write some text and then it would do some analysis, and rather than them having hundreds of GPUs back home to do the inference, they could just use your computer to do the inference.
Yeah, so maybe follow-up questions. In your opinion, you've got some examples there, like what open up for developers in this company, available and passing it in the browser.
Yeah, so the question is, like, what does it open up? Is a good question. I think the main thing that I think it opens up is kind of really innovative ways of interacting with AI, insofar as it allows the interaction to be a lot faster. And the other thing it kind of opens up is, like, just more available. But like, I don't fully know. Like what I want to get at is, like, it's much easier, if you will, to deploy a model in the browser than to have the back-end infrastructure to support a bajillion people accessing my model at the same time. So I think in that sense, it, like, actually makes deploying AI easier, if that makes sense. Yeah. Any other questions?
Do you think there are, like, privacy concerns, so, like, browser's got access to all that data that makes them the issue.
Totally. I think actually the privacy concern goes the other way around. So it depends how much you trust people, but I think Apple or someone makes classic comments like, we never send your data away to do training or inference. We like keep it on the phone. This is the same deal. So basically, if you trust me, I can say, well, I'm never going to take your data to my server. You write whatever you want, and I'll do inference on it, and it never leaves your computer, if you will. So actually, I think it can help a little bit. Some work to be done there, but yeah. Any other thoughts?
Just on that, you've got a number of regulations going on around the world in Illinois, I think, and California. They've got the, you're not allowed to collect any identifiable information, including pictures of faces, without permission. Yeah, so that goes to
Yeah, totally. Yeah, so I think the main thing, like most of this slide is clear. The main thing I want to say is like you do typically downgrade your model to deploy it to the web. So the one downside is it can get a little bit worse accuracy at the cost of faster. And then there's just some other kind of software engineering issues. Just one little thing I want to bring up is I think that this kind of this field of like the UX of UI is very underanalyzed. If you will, it's a big hole. The point is like there's heaps of work to do here. And so there's some people doing a little bit of thought about these kind of creative AI interfaces. Basically, well, I'll have on my right a whole bunch of little specialized AI drawing assistants. And when I want to draw something, I'll activate them in different ways, and maybe this one will color in my trees. And this one will kind of complete pictures for me and so on. I think this is just one example. There's a lot of things to do here. Thoughts? Yeah. Yeah, cool. Any other thoughts?
Interesting. Well, switching on the UX is right. What's the UX of 87% accuracy?
Yes.
Like, I'm not sure too many people have dealt with the inaccuracies of AI and how that might affect a user and their user. Press in, this is no address. Where do we stand now as a user with this application? And you're like, but it isn't. It is address.
Yeah, I think like you make a very solid point. I think the issue around the kinds of mistakes that AI systems make compared to humans, how humans should be allowed to interact with the answer proposed to them, I think it's all really, 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 really important. I know when I'm chatting to people about making promises about how well an AI system will work or something like that is can be very interesting. Yeah, definitely. Any other thoughts? Okay, well, I think, yeah, that's all I had. So thanks for your time. So I work at this company called The Brain Shop, and we're doing a workshop later on this year about kind of helping companies adopt AI. So thanks for your time. Bye.